University, Lucknow. Today, I'll discuss data independence. Data independence is defined as a property of DBMS that helps you to change the database schema at one level of a database system without requiring to change the schema at the next higher level. Data independence help you to keep data separated from all programs that make use of it. You can use this stored data for computing and presentation. In many systems, data independence is an essential function for components of the system. In this tutorial, you will learn what is data independence of database management system, types of data independence, levels of database, physical data independence, logical data independence, difference between physical and logical data independence, and importance of data independence. So let us start this tour. Types of data independence. In database management system, there are two types of data independence: logical data independence and physical data independence. As far as levels of database is concerned, before we learn data independence, a refresher on database levels is important. The database has three levels as shown in the diagram, that is physical and internal level, conceptual level, and external level. We have actually read this in database management architecture class. So this is just a refresher because it is very relevant at this stage. So database management system architecture diagram is before you. You are seeing the external layout view, that is the end users view, where you are seeing in the picture there are view 1, view 2, and view 3. There are three views and three people of different generations are working on computer. So they definitely might be working with their own convenience and their own choices, means they are seeing the different views of the same database. So this is view level or users end users level or external level. And the conceptual layer, this conceptual schema where the relation of all the data is defined and maintained. And at the physical layer, the physical schema where the database is stored, how it is stored and where it is stored, all these things are described at this level. So what is the relation of this diagram with our topic? Let us see here. In NSI Spark 3-tier architecture, in the last lecture we have discussed this diagram. Now we can easily see that we apply logical data independence at external level. So the logical data independence is applied at external level. Here, logical data independence means that by viewing the same database from view 1, the same database from view 2, and the same database from view 3 or up to view n, how many views we are using, but there should not be any change in database. Means we see the data in a different way, but that should never change the database. This is something called as logical data independence, which is applied at the external level or view level, right? I hope with this diagram this concept must be pretty more clear. So now we move towards physical data independence. Physical data independence is applied at conceptual or logical level. Here at the conceptual schema, the physical data independence is important. Why? Because it is at this level, and with the help of physical data independence we ensure that there should not be any change if we make any change in the physical database. That is, if we change the database source or we change the storage, it should not be changed. So this is called physical data independence. Now let us take an example of university database. Consider an example of a university database at the different levels. This is how the implementation will look like. Type of schema, implementation and external schema. So this is type of schema. View 1, you will see course information, that is CID, integer type, CNAME, string type. Student info, that is view 2, ID, integer type and name, string type. So this may be, this is internal schema. You will see this at external level. View 1 and view 2 you might be showing in the diagram. You must have seen in the diagram. Then at the conceptual schema, student definition, the database definition must be given, like ID is equal to integer type, name is a string, login is string, age integer, like that. And courses, ID is integer type, name, course name is string, and credits is integer. Enrolled, ID is integer and grade is a string, like that. So all this definition will be given in conceptual schema. And at physical schema, relations stored as unordered files and index on the first column of the students. So this these two things are at physical schema. So this is physical schema, this is conceptual schema, and this is the external schema. So this is just we have seen with the example of a university database what happens at the different level. The schema works like this, means we have these definitions at the view level, we have these definitions at the conceptual schema level, the definition of all the data and their types and the relation amongst them. So it is described at the conceptual level or conceptual schema. And physical schema, the relations are stored in as unordered file and index on the first column of the students. So this is at the physical level. So this is what we can understand with the help of a example of university database. Now we'll see physical data independence. Physical data independence helps you to separate conceptual levels from the internal or physical levels. It allows you to provide a logical description. Listen carefully. It allows you to provide a logical description of the database without the need to specify physical structures. Compared to logical independence, it is easy to achieve physical data independence. So we repeat this, the physical data independence helps you to separate conceptual level from internal or physical level. It allows you to provide a logical description of the database without the need to specify physical structures. And it is easy compared to logical independence, it is easy to achieve physical data independence. With physical independence, you can easily change the physical storage structures or devices with an effect on the conceptual schema. Means if we have physical independence, we can easily change the physical storage structure or devices with an effect on the conceptual schema. Any change done would be absorbed by the mapping between the conceptual and internal levels. Physical data independence is achieved by the presence of the internal level of the database and then the transformation from the conceptual level of the database to the internal level. So physical data independence is, if it is present, we can easily change our storage structure or devices. Suppose we change the hard disk of the system. This is the change of device. With the change of device, the data should not be affected. And suppose we change the storage structure, we change the structure of the database. By that also, if the data is not changing, there is no effect on database, we can say that we have achieved physical data independence. So physical data independence ensures that by the changing of physical storage structure or device, the data should not be changed. The data is never changed. and any change done would be absorbed by the mapping between the conceptual and internal levels. So physical data independence is achieved by the presence of the internal level of the database and then of transformation from the conceptual level of the database to the internal levels. So I hope by this description and example you must have understood physical data independence. Finally, in a nutshell, we can say that if we change the storage devices or storage structure, there should not be any change in the database. If it is so, we can say that we have achieved physical data independence, or there is physical data independence present in our database. Now we will move towards the next topic, and before that, we can see the examples of changes under physical data independence. Due to physical independence, any of the below change will not affect the conceptual layer. Using a new storage device like hard drive or magnetic tape will not affect the conceptual layer. Modifying the file organization technique in the database will also not affect the conceptual layer. And switching to different data structures will not affect the conceptual layer. And changing the access method also should not affect the conceptual layer. And modifying indexes should also not affect the conceptual layer, and changes to compression technique or hashing algorithm also should not affect the conceptual layer. And the change of location of database from say C drive to D drive or any other partition that we have made so far, so it should also not make any change, or it should not affect the conceptual layer. If it is so, we can say that we have achieved physical data independence. I hope by giving these many examples, physical data independence must be pretty clear in your minds. So now we move to next topic, that is logical data independence. Logical data independence is the ability to change the conceptual scheme without changing external views, external API or programs. Any change made will be absorbed by the mapping between external and conceptual levels. When compared to physical data independence, it is challenging to achieve logical data independence. So we can further see this. Logical data independence is the ability to change the conceptual scheme without changing external level, external view or external API or program. So at the conceptual level, uh, this scheme works without changing the views. Now, examples of changes under logical data independence. Due to logical independence, any of the below change will not affect the external layer. Suppose we add, modify or delete a new attribute, or any new entity we add, modify or delete, or we add, modify or delete any relationship. It is possible without a rewrite of existing application programs. So if we have this liberty, then we can say that logical data independence is present. And suppose we merge two records into one, it should also not affect the external layer. Or suppose we break an existing record into two or more records, it should also not affect the external layer. Means the view level should not be changed by these changes. Suppose we add, modify, delete a new attribute, or we add, modify, delete an entity, or we add, modify, or delete a relationship without a rewrite of existing application program. It is possible, and it should not change the affect the view level. It should not affect the view level. So if it is so, we can say logical data independence is there. And suppose we merge two records into one, then also it should not change the external level. or suppose we break an existing record into two or more, it should not also affect the external layer. So if it is so, we can say the logical data independence is present in our database. Now come to the difference between physical and logical data independence. In logical data independence is mainly concerned with the structure or changing the data definition, whereas physical data independence is mainly concerned with the storage of the data. In logical data independence, it is difficult as the retrieving of data is mainly dependent on the logical structure of the data. So it is difficult to achieve, whereas in physical data independence, it is easy to retrieve. Next point is compared to logic, physical independence, it is difficult to achieve logical data independence. Compared to logical independence, it is easy to achieve physical data independence. Moving further, in logical data independence, you need to make changes in the application program if new fields are added or deleted from the database. In logical data independence, you may have change in the application programs. In physical data independence, a change in the physical level usually does not need change at the application program level. If we change at the physical level, it does not change at the application program level. We need not to change the application program. And in logical data independence, modification at the logical level is significant whenever the logical structures of the database are changed, whereas modifications made at the internal levels may or may not be needed to improve the performance of the structure, that is physical data independence. Then concerned with conceptual level schema. Logical data independence is always concerned with the conceptual schema, whereas the physical database independence is concerned with internal schema. The logical data independence, the example is add, modify, delete a new attribute. In physical data independence, the example may be change in compression technique, hashing algorithm, storage devices, etc. So these are the examples of logical data independence and physical data independence and the differences between physical and logical data independence. Now we come to the importance of data independence. What is the importance? What it does? What liberty it gives us? What facility we get by data implementing data independence, by achieving data independence? So now let us have a look on importance of data independence. Data independence helps you to improve the quality of the data. By achieving data independence, we improve the quality of the data, and database system maintenance becomes affordable. So if it is so, database system maintenance becomes affordable. We can easily maintain the database system by achieving data independence. Enforcement of standard and improvement in database security. This is also happens by achieving data independence, and you don't need to alter data structure in application program. In application program, we never need to change or alter data structure. It permits developers to focus on the general structure of the database rather than worrying about the internal implementation. Let us see it once again. It permits developer to focus on the general structure of the database rather than worrying about the internal implementation. And data independence allows you to improve state which is undamaged or undivided. And by data independence, database incongruity is vastly reduced. And by data independence, we can easily make modifications in the physical level is needed to improve the performance of the system. So these are the benefits we get by data independence, and that's why the data independence is very important. These are the importance of data independence. So I hope by this description, the data independence, their kinds and differences must be clear in your mind. Now, let us come to the conclusion and summary of this particular discussion of data independence. Data independence is the property of database management system that helps you to change the database schema at one level of a database system without requiring to change the schema at the next higher level. Two levels of data independence are number one physical and number two logical. These are the two level, that is physical level and logical level. Physical data independence helps you to separate conceptual levels from internal and physical levels. Once again, it is important, let us revise this. Physical data independence helps you to separate conceptual levels from internal or physical levels. Next is logical data independence is the ability to change the conceptual scheme without changing. Now, when compared to physical data independence, it is challenging to achieve logical data independence. Then, data independence helps you to improve the quality of the data. This is very, very important. So, by this, we can say that database independence or data independence is a property of the database that gives us many advantages, and that's why it is very, very important. It actually helps us to improve the quality of the data, and by this, if we improve the quality of the data, the maintenance of the database becomes very easy. And we, in a nutshell, we should say that a good database must achieve data independence or must possess data independence. So it is a kind of property which makes the database management system standard high. So I believe that by this description, differences, examples, and summary, the topic of data independence must have been very clear in your minds. So thank you all for your patient listening. You had been a very good listener, and I hope that you feel comfortable now in the topic data independence. You are always welcome. In case of any doubt, you can ask me anytime, online or offline. Thank you. Thanks a lot.